The last unit in our section of our section in Unit 10 of our Statistics OER course mentions the other chi-square tests. This we will not cover them in detail except for one extra credit Excel project for the test of independence, but you need to know that there are other ways that the chi-square distribution can be used. These are actually very popular tests in statistics investigations and studies, and you need to be familiar with them and also know that they exist. You realize, of course, that the Art of Stat apps offer in the chi-square test the option for you to do a test for independence or homogeneity. So this is the first of the tabs, and we have been using the goodness to fit for the purposes. Also, in the introductory statistics book by OpenStax, as well as the introductory statistics co-requisite book by Lumen, there are specific sections for the test of independence, section 11.3, and the test for homogeneity, section 11.4. We will just do a summary of them, and there will be some questions in your homework in Lumen to select which test you would use. So the chi-square test for independence is used to test the hypothesis that two factors are independent. Remember that two events are independent if and only if the probability of their intersection occurring, of them both occurring, equals the probability of each one times the probability of the other one. So the product of the probabilities of each of those events. These will be the expected values if you are testing for independence. So you will assume that in your null hypothesis that the two events are independent, and you will have expected values equal to the products of the individual probabilities. Tests of independence involve a contingency table, and your test statistic will be the sum of the Pearson residuals, or the observed minus expected square divided by expected for each one of the boxes in your table. That gives two labels to your attributes. One is the row and one is the column. I is the number of rows in your table, and J is the number of columns in the table. And for this reason, you will have I times J groups or categories that you will be looking at. O again is the observed value, E is the expected value, and there will be I times J Pearson residuals in this sum. The test for independence will always be right-tailed. The number of degrees of freedom will be rows minus 1 times columns minus 1, so I minus 1 times J minus 1. The formula for the expected number of outcomes is E equals the row total times the column total divided by the overall total surveyed. And note here, the expected value for each entry in the table must be at least 5 for us to be able to use the test. If you have values that are less than 5, you will have to combine categories. The chi-square test for homogeneity can be used to draw a conclusion about whether two populations have the same distribution. I want to draw your attention to that. The book discusses the option for two populations. It is possible to do a test for homogeneity for more than two populations, but our book mentions only two populations and assumes that each of the populations will go in its own row in the contingency table. So the null hypothesis here will be that the distributions of the two populations are the same, so it's a homogeneous distribution for either of the two. And your alternative hypothesis will be that the distribution of the two populations are different. The test statistics are calculated exactly like in the independence test. So you will calculate those Pearson residuals. They will be observed minus expected square divided by E, and then you will add those. It's a test statistic one chi-squared value, and you will add those Pearson residuals to find your test statistic. Let me change this typo here. Make sure you change that in your notes. The test for homogeneity is always right-tailed, and the number of degrees of freedom is columns -1. However, this is because the book mentions two populations. If you had more than two populations, then you would have more than two rows in the table. So actually the degrees of freedom for this test will be columns number -1 times the number of rows -1. When you have two populations, then you have number of rows equal to 2, and therefore 2 minus 1 is equal to 1, and this is why the book says that the numbers of degree of freedom is degrees of freedom equals number of columns -1. So in the general scenario where you will do homogeneity for multiple populations, then the degrees of freedom will equal the same that you would do for independence. Number of columns -1 times number of rows -1. So for two populations, number of rows -1 is equal to 1. And therefore the degrees of freedom then, they would just equal to the number of columns -1. Note here the expected value for each entry in the table must be at least 5 for you to be able to use this test. So which test are we using? And there will be some homework questions for you on that. We will use the goodness of fit when we have one sample and we want to know if the population fits the given distribution. Our null hypothesis will be that the single population fits the given distribution, and the alternative hypothesis would be that this single population does not fit the distribution. Test for independence, we will have one sample, and we will ask ourselves if there is an association between the two categorical variables. One will be a row, and the other will be the column descriptions. So, the null hypothesis will be that the two variables or factors are independent, and the alternative will be that the two variables are dependent. When we are doing homogeneity, we have two or more independent samples, and we want to know if the populations follow the same distribution. The null hypothesis will be that the two or more populations follow the same distribution, and the alternative hypothesis will be that the two or more populations do not follow the same distribution. Be careful here when you are doing homework. The degrees of freedom will be columns -1 if you have only two populations, but it will be columns -1 times number of rows -1 if you have more than two populations.